And here's the final video solutions for problems 16 to 21 from the Unit 1 review. So for 16, we're asked to determine if the relation defines y as a function of x. So here, we just want to make sure all the x values are different, and they are, so yes, this would be a function. In other words, no 2 points would line up vertically. But for B, if you take a look, the 7s repeat, so those 2 points would line up vertically, not a function. For 17, we were asked to evaluate this. For A was f of 0, so this just becomes negative 2 times 0 squared plus 4 times 0, well that's just 0. B, f of t, just substitute a t in wherever we see an x, so it's negative 2t squared plus 4t. That's all we can do with that. C was f of negative 1. Carefully evaluate. Negative 2 times negative 1 squared plus 4 times negative 1 gives us negative 2 times 1, and then this will give us a minus 4. So this is negative 2 minus 4, which is negative 6. D was f of 3. So this becomes negative 2 times 3 squared plus 4 times 3. We get negative 2 times 9 plus 12. We get negative 18 plus 12, which gives us negative 6. And then for E, we have f of x plus 4. So we have negative 2 times the quantity x plus 4 squared plus 4 times the quantity x plus 4. So we need to expand this. So we're going to have negative 2 x plus 4 times x plus 4. We could distribute here, so we'll get plus 4x plus 16. If I don't distribute the negative 2 just yet, I always advise to leave that at the very end. Let's go ahead and multiply those two together first. That will give me an x squared on the outside plus 4x on the inside plus another 4x and then plus 16, then plus the 4x plus 16. Distributing the negative 2 now, we'll get a negative 2x squared minus 8x minus 8x minus 32. So I just distributed the negative 2 to all 4 of those, plus 4x plus 16. Combining like terms, we have the negative 2x squared. We have a negative 8x, so that's a negative 16x plus 4x is a negative 12x, and negative 32 plus 16 is a minus 16. All right, for question 18, we are asked to find the domain. So whenever we have a fraction, the denominator cannot equal 0. So what do? We set it equal to 0 and figure out what would cause it to be 0, and that's when x is 5. So in other words, this means x cannot equal 5. So we'll say, so x cannot equal 5. Therefore, the domain is all numbers except this. So we could say negative infinity to 5, but we can't include it, and then we pick back up, we join it with 5 to infinity. Now for B, we cannot have a negative underneath the radicals, so we need to set 2x minus 3 greater than or equal to 0, because it could be 0 or it could be larger than it. And as we solve this, we'll add 3 divided by 2. So our domain would start with the 3/2 and go to infinity. 19, we were asked to graph here. So the first two we have to get in slope-intercept form. So here I'm going to add 2x to each side. So 4y is going to equal 2x plus 8. Divide everything up here by 4. So y would equal a positive 1/2 x plus 2. So if we go over here and graph this, all of my squares just count as one unit. I start at 2 on my y-axis. My slope is positive 1/2, so I count up 1, 2 to the right, up 1, 2 to the right, or I can count down 1, 2 to the left. And then I'm going to draw a line going through that. And then I'm going to label this as A. All right, for B, I'm actually just going to switch this around. 5y equals negative 4x because I want to get the y by itself. So I'm going to divide by 5. So we get negative 4/5 x. So that means my y-intercept is actually 0. And then I'm going to count down 4 units and then 5 to the right. I can count down 4 more and 5 to the right. Or I can go up 4, but then 5 to the left. And we'll draw a line through that. And we'll call this B. All right, now for C, x equals -6. If you recall, x equals a number would be, vertical. A vertical line going through -6 on the x-axis. So that'd be right here. We're going to draw a vertical line going right through that. Call that C. Now D, this would be a horizontal line going through 3 on the y-axis. So right here, I'll draw a horizontal line. And those are the graphs for number 19. Okay, for 20, we were asked to find the slopes. We're using the slope formula. Remember, that's y2 minus y1 over x2 minus x1. So very carefully, and we can call this x1, y1, x2, y2. You could set this up this way too when you're using the midpoint or the distance formula. And this is going to sound a lot like the distance formula because we're subtracting here. The midpoint is the only time we add the x's and the y's together. So I'm going to start with -4 minus a -2 over -12 minus 4. So we're going to have a -4 plus 2, and this will give us a -16. So we'll get a -2 over -16, which turns out to be a positive 1/8. All right, and then our last problem has 4 parts to it. Here we're going to write the equation of the line, having the given conditions. Write the answer in slope-intercept form, if possible. So here we have our slope already. This is how I set it up in class. Our slope was already given to us. I'm going to use y equals mx plus b to find b. So this is my x, this is my y. So I'm going to have -7. My slope is 3. My x is -2. What's nice is there's no fractions. Multiply, we'll get a -6. Add -6 to both sides, so we'll get a -1 equals b. So then our equation is y equals 3x minus 1. Now, if you wanted to use point slope form, I'll still show that. Because you never know if on the final exam you're going to be asked to find this as well. So we could do y minus our y1, so that's a -7, equals m times x minus x1, so that's x minus a -2. So we get y plus 7 equals 3 times the quantity x plus 2. So we get y plus 7 equals 3x plus 6. Subtract 7, y equals 3x minus 1. And they match. All right, B is actually a little bit nicer. You guys recall finding the x and y intercepts. Here x is 0, so guess what? 5 is the y-intercept, so that means B is 5. And we have our slope, so we don't need to do any work. Our equation is y equals -2/5 x plus 5. C and D, we definitely have to do some work here. Let's first find the slope. So our line goes through the point 2, -6, and is parallel to the function defined by 2x minus y equals 4. So I want to start with that. I want to find the slope of this line. So I'm going to subtract 2x. I want to divide everything up here by -1. So y is going to equal 2x minus 4. So this slope is 2. The slope of our line is also 2. So now I can use y equals mx plus b, or point slope form. So I'll have -6 equals 2 times 2 plus b. -6 equals 4 plus b. So b is going to equal -10. So our equation is y equals 2x minus 10. And the last one, our line passes through the point -2, 3 and is perpendicular to the line defined by 5y equals 2x. And we're going to start with that again, the equation, to find the slope. So just divide by 5, so y is going to equal 2/5 x. So the slope here is 2/5. Our slope is the opposite, so we need negative reciprocal, so negative 5 halves. Then we're going to use y equals mx plus b. So we'll have 3 equals negative 5 halves times negative 2 over 1 plus b. So this will give me a positive. The 2's will divide out. I'll get a positive 5. Subtract that, b is going to equal negative 2. So our equation is y equals negative 5 halves x minus 2.